So this is going to be a bridge rectifier. Bridge rectifier. Here we can observe only 4 diodes connected in like a bridge, and 4 diodes will be in the bridge arms, and at the center one resistor, that is nothing but my load resistor, and input is given to the 2 other terminals of the bridge. So here we cannot find any transformer, so center tapping headache is removed, and also moreover we can observe one thing, that by using this bridge rectifier we will get the output same as in the full wave rectifier. But what is the advantage with this is that the peak inverse voltage will be across the diodes will be reduced. That is, in the previous case, that is in the center tap transformer full wave rectifier, we will have a peak inverse voltage of 2V maximum at the diode which is not conducting, otherwise which is in the reverse biased mode. So here in this type of connection, peak inverse voltage across a diode is reduced. So this is the main advantage, and this is the rectifier which is used in our power supplies which are used in your laboratories. So this is the modified version, and this is the latest version of improved version of your rectifier. Now how the conduction will take place. Here input is given at these 2 terminals, and this is, if I give a positive half cycle, then this will become plus and this will become minus. So if it is plus, then this will be forward biased. This diode will be forward biased. Why this will be forward biased means this is plus and this is also plus. And here this is minus and this is plus. So this will be reverse biased. And again the current will flow in this direction and flow through this and go in this way and reach the negative terminal. So the circuit will be completed. The circuit will be completed. So during the positive half cycle, diode T2 and D4 are conducting, and they will produce a half cycle like this at the output. And during the negative half cycle, this will be minus and this will be plus. So what happens? So during this diode will be forward biased and the current will enter in the same direction. That is, this is in the previous case the current is entered in this direction, and in this case also the current will enter in this direction. So this diode, it will cross the resistance and go in this way, and then it will reach the negative terminal. So in this way, for each positive or negative, for each half cycle, two diodes will come into conduction, and this is the mode of conduction of the bridge rectifier. And now the output will be same, the calculation will be same, and finding the ripple factor is same as in the full wave rectifier with the center tapped connection. So then మనం నేర్చుకోవాల్సిన అవసరం లేదు. But what we have to see is that what is the peak inverse voltage, that we have to see. So if for the positive half cycle, this diode and this diode are on, these two are. So if I consider that these two diodes will have a voltage drop of 0, then what happens? So total voltage will be dropped here. Total voltage will be dropped here. And if I draw a loop equation, so one diode, if I draw a loop equation like this, so this drop will be 0 and this diode will be open. So whatever voltage is coming here, that will be the voltage across this. So my peak inverse voltage in the diode which is not conducting is going to be Vm. That is peak inverse voltage will be V maximum. The same thing will happen for the other loop also. So this is the modified version of your rectifier.